So this lecture will be about introduction to challenges in water management in cold climates. I will not only be talking about the Arctic climate, but also colder climates. My name is Harsha Ratnavira. I'm a professor in water and wastewater engineering at the Norwegian University of Life Sciences. So first of all, the first question which we get into mind is that where is the cold climate and how do you define the cold climate? So there are different definitions. One could be that regions with annual mean temperature below a certain degree, or you can also use the geographical position below or above a certain latitude. One of the definitions are related to the AMAP system. That's the Arctic Monitoring and Assessment Program, which has been going on for now quite a long time with the collaboration of many countries in the Northern Hemisphere. And the definition according to AMAP is that the brown or the orange line which you see, that is the 10 degrees isotherm for July. That means the area or the regions where the average temperature in the July month is 10 degrees of Celsius or below. We all have heard about the climate change, and one of the main impacts of climate change is the increase of air temperature. The simulations and observations so far shows that the Arctic area's temperature rise could be much higher than the global temperature rise. So the first figure shows the annual mean global temperature increase. The blue line or blue area shows one scenario, rows and lines show the other scenario. So the global temperature increase by 2100 is about 2 degrees, the moderate, and the 4 to 5 degrees in the high temperature change scenarios. But the middle figure shows that how the Arctic mean temperature increases, and you can see that Arctic mean temperature, the annual mean is around 5 to 6 degrees increase, or it could also be as high as 8 to 12 degrees. It's even worse during the winter. The last figure shows that it could be between 6 to 9 degrees, the lowest, and the high scenario could go up to even 15 degrees increase, which could have many negative impacts, but there could be some advantages as well. So for example, water treatment and wastewater treatment technologies or processes, they will in most cases will benefit by having higher temperatures. If we look at the world's average temperature, this figure shows that the northern part of the world has temperatures below zero, and when the air temperature is going down, we can also anticipate that the wastewater temperature is also going down, and water temperature is going down, which means that one needs to have larger facilities to have equally good treatment efficiencies during summer and winter. So in summer, maybe the processes function in normal conditions, and in winter they will get slow. The biological processes, the microorganisms work slower, coagulation process, the flock building gets slower, and even the sedimentation processes become slower. So all these processes are affected, and when you want to build a treatment plant or design a treatment plant for colder climates, you have to think about that, so that you should dimension your treatment plant in such a way that it will also give the same level of treatment efficiencies both in winter and summer. Snow coverage is also an issue. The Arctic areas and colder areas, we see that there is an increased coverage of snow. Some areas there could be snow coverage for several months. This figure shows the days of the year where the surface is covered with snow. So the greener it shows that the higher the number of days which are covered by snow. So imagine that your drinking water treatment plant, or especially the wastewater treatment plant, is an open landscape. You have an open biological tanks or open dams. Then it will be covered by snow, which means that from one side your wastewater will be highly diluted because of the snow, and also the temperature will go down. This is one of the reasons that most treatment plants in Norway are either covered or inside the rocks. But in the Arctic area, some changes are taking place, and here this figure shows that how the snow cover in 2002 during the June month relative to 1971 to 2000. So the brown areas, the dark brown means that the number of days snow cover area is reduced by 40% compared with 1971 to 2000 area. Another issue is the permafrost. In colder areas, especially in Arctic areas, the permafrost could be much thicker than other areas. So in this figure, the light brown part shows the permafrost thickness of above 5 meters, and the dark brown means that less than 5. Dark brown is 5 to 10 meters. So imagine that you need to put your water pipes and wastewater pipes below the permafrost layer, which is the norm in generally in cold areas, so that your pipes will not be burst or deformed. But if you have to dig 5 meters or longer, then it is not going to be economical, not only to construct but also to maintain and rehabilitate. So this means in most cases in Arctic areas or where the permafrost is much thicker, you have to find other solutions. The most common solution is to have pipes above the ground. Another challenge in colder climates is the low population density. This figure shows the population density in the world, and the white and white yellowish color shows that about 1 person per square kilometer, which means that if you have to build a centralized wastewater treatment plant or centralized water supply system, you have to have long or very long pipelines. Constructing long pipelines means huge investments, not only in construction period but also the operational time, because you need to have energy and pump it to pump the water or wastewater. So in generally we say that scarcely populated areas, which are also necessarily the colder climate related areas, in this context it is more expensive to build centralized water and wastewater treatment facilities, and therefore the attractiveness for decentralized systems are increasing, so must be considered carefully. So water pipes could be frozen during the winter. You have to have protection against freezing. In most cases it's not only insulation but also heating of the pipes, and then the frost heaving issues you have to think about when you are designing pipes and other infrastructure elements. You have to think about what will happen during freezing temperatures, and you could also expect leakages from drinking water pipes and wastewater pipes during extreme colds and freezing time, because the pipes could be burst. There could be some positive things also related to water supply and wastewater management in colder climates, and especially related to the climate change, because we have heard that when the temperature is increasing, the snow coverage, precipitation, and ice coverage will be reducing, which means that there will be more water. And when the air temperature is increasing, it might also have some positive impacts on the wastewater treatment and water treatment. So for colder climates, it says generally groundwater is a good source for drinking water, but during the winter periods one can also use lakes and even rivers, because there will be low sedimentation. But groundwater has this advantage of percolation through a high soil layer, and especially if it is coming below the permafrost layer, then you can have a raw water with very good quality. Water from active permafrost layer or below impurity could be impurities. Water treatment could be required, because this part of the water could be polluted from various anthropogenic pollution sources. As I said, water quality in winter is usually good, but in summer it could be bad due to the increased sedimentation, transport, and erosion. So in summer you need to have systems where you can have a better treatment systems. Infrastructure is stressed by extreme events, so we need to think about that. The rehabilitation costs and maintenance cost will be higher, and treatment processes in general, when the temperature is increasing, the processes are easier to run, but still we are talking about lower temperatures, so which means that the treatment processes operational cost in colder climates are in general higher than in warmer climates. So these are in general the challenges what we have to expect in a colder climate, and especially in Arctic climate. Thank you.